Welcome to a slow, beginner-friendly lesson on conditions and the if statement, made for absolute beginners. Branching begins here. Today you learn the most important idea in programming after functions: how to make your code decide. Until now, your scripts ran top to bottom, doing every line in order, no exceptions. Real programs are not like that. They ask questions. Is the user logged in? Is the score above 50? Is the email valid? Based on the answer, the program takes one path or another. That power to choose comes from one small word: if. Today you meet if. The power to choose. Look at what you can do so far. You can store values in variables. You can call functions. You can loop over collections. But every line runs in order, top to bottom, with no exceptions. Real programs need more. They need to ask questions and act on the answer. Is this user allowed in? Is this number positive? Is this list empty? Today you learn how Python asks those questions and chooses what to do next. The tool is the if statement. From lines to branches, every program reaches moments where it must choose. Today you learn how Python makes that choice. Every program chooses. Here is the simplest if statement. Age equals 20. Then, if age is greater than or equal to 18, print you can vote. Two things matter on that first line: the word if, and the colon at the end. Below the colon, the indented line runs only when the condition is true. Age 20 is greater than 18, so the message prints. Hold this shape in your mind: the word if, a condition, a colon, and an indented body underneath. The shape of every if. Picture your program walking forward, line by line, like someone walking down a path. Then it reaches a question, a fork. The question has only two answers: yes or no, true or false. When the answer is yes, the program takes one path. When the answer is no, it takes the other. After the fork, both paths rejoin and the program keeps walking forward. That is what branching means. A decision point that splits the flow for a moment, then brings it back together. Every if works this way. A fork, then a rejoin, one question, two answers. The shape of every decision in code, and the shape of every if statement. One question, two paths. Remember def and for? They both ended with a colon, and the body was indented underneath. If works exactly the same way. The if line ends with a colon. Everything you want to run when the condition is true gets indented below, usually by 4 spaces. When you stop indenting, the if body ends. Python uses indentation to know which lines belong to the decision. Get the colon wrong, or the indentation wrong, and Python will tell you with a syntax error before the program even runs. Colon then indent. After the word if, you write a condition. The condition is any expression that evaluates to true or false. Not a string, not a number, a boolean. Python evaluates the condition once, gets true or false, and that single answer decides what runs. If the answer is true, the body runs. If the answer is false, the body is skipped. Every if in Python comes down to this one question: is the condition true, or is it false? A boolean, every time. Temperature equals 30. The condition asks, is temperature greater than 25? 30 is greater than 25, so the answer is true. The indented body runs and prints it as hot. Then the program continues to the next line outside the if. Print done always runs, because it is not indented. Notice the structure. The indented line belongs to the if. The unindented line does not. Indentation is how Python knows what is inside the decision and what comes after it. True means run, true or false. The only answers a condition ever gives. One runs the body, the other skips it. Only two answers. Now temperature equals 10. Same condition: is temperature greater than 25? 10 is not greater than 25, so the answer is false. The body does not run. Nothing about hot is printed. The program simply jumps over the indented line and continues. Print done still runs, because it lives outside the if, unindented. This is the heart of branching. When the condition is false, Python skips the indented body entirely and moves on as if it were not there. False means skip. Trace what happens when Python meets an if. First it evaluates the condition, once and completely, and gets a single answer, true or false. If true, execution steps into the indented body and runs every line there, top to bottom. If false, execution jumps over the body entirely, skipping every indented line. Either way, after the if, the program continues with the next unindented line. Two paths for a moment, then the flow comes back together. That is the whole mechanism of an if statement. Trace it slowly. How do you build conditions? With comparison operators. Double equals checks equality, age equals 20 gives true. Exclamation equals checks the opposite, not equal. Less than, greater than, less than or equal, greater than or equal. Every one of these produces a Boolean, true or false. That Boolean is exactly what if needs. You write if, you write a comparison, Python reduces it to true or false, and the decision is made for you. Comparisons make Booleans. Here are the 6 comparison operators in one place. Double equals means equal to. Exclamation equals means not equal to. Less than and greater than are the strict ones. Less than or equal, and greater than or equal, include the boundary. Notice that equality uses double equals, not a single equals. Single equals is for assignment, double equals is for comparison. Mixing them up is the most common beginner mistake. Say equals equals out loud when you mean comparison. 6 tools, memorize them. Conditions combine. And demands all. Or accepts any. Not flips the answer. 3 small words, enormous power. Small words, big power. Sometimes one condition is not enough. You want 2 things to be true at once. That is where and comes in. Age equals 25, has it equals true. The condition, age greater than or equal to 18 and has id. Both must be true. Age 25 is old enough, true. Has it is true, true. True and true gives true, so entry allowed prints. If either side were false, the whole thing would be false. And demands every part to hold. Use and when all conditions must be true together. All must hold. Other times, you want any one of several things to be true. That is where or comes in. Day equals Saturday. The condition, day equals Saturday, or, day equals Sunday. Only one needs to be true. Day is Saturday, true. The other side does not even matter, or already has its true. Weekend prints. Or is more forgiving than and. One true is enough. Use or when any of the options should trigger the action. One is enough, not flips a Boolean to its opposite. Logged in equals false. The condition, not logged in. Not false becomes true, so the body runs and please log in prints. Not is how you ask the opposite of something. Instead of writing if logged in equals false, you simply write if not logged in. It reads like English and means exactly the same thing. Not is especially useful with Boolean variables that already represent a yes or no answer. Flip the answer. Here is a subtlety beginners often miss. Python lets you write if followed by almost anything, not just a comparison. The rule is truthiness. An empty string is treated as false. The number 0 is false. An empty list is false. None is false. Anything with content, a non-empty string, a non-zero number, a list with items, is true. So if name, where name equals Ada, is true. If name equals empty string, is false. Truthiness lets you write clean and readable conditions. Empty means false. If is the foundation. Else and elif stand on top of it. Master if, and the rest follows. The foundation of branching. Step back from Python for a moment. Everyday life is full of if statements. If it rains, take an umbrella. If the door is locked, use the key. If the bus is late, walk. You make dozens of these decisions every day without thinking. Programming just makes the decision explicit. You write the condition, you write what happens when it is true. That is all if is, a written down version of a decision you already make constantly. The concept is familiar. The syntax just takes practice. You already think in if. The body of an if can be more than one line. Score equals 90. If score is greater than or equal to 90, 3 things happen, all indented under the if at the same level. Print excellent, print keep it up, and set grade to A. All 3 run together when the condition is true. When you stop indenting, the if ends. Print done is outside the if and always runs. As long as lines share the same indentation, they belong to the same decision. Indent together, run together. Quick self-check. Can you name the parts of an if statement, the word if, the condition, and the colon? Can you say what kind of value the condition must produce, a Boolean, true or false? Can you explain what happens when the condition is false, the indented body is skipped? Can you name at least 3 comparison operators? If any of these feels shaky, rewatch the matching part. These basics must feel automatic before you add else and elif in the next lessons. Say each out loud. Here is the lesson in one breath. An if statement lets your code make a decision. You write if, a condition, and a colon. The condition evaluates to true or false. If true, the indented body runs. If false, the body is skipped and the program continues. Comparisons like equals equals, not equal, less than, and greater than produce the Booleans that if needs. You can combine conditions with and, or, and not. This is the foundation. Everything else about branching builds on it. The whole lesson, one breath. Today you learned if, the foundation of branching. But if alone only handles one case, do this when the condition is true. What about when it is false? That is what else is for, the alternative path. And what if you have more than two cases? That is what elif is for, chaining many branches together. Those come in the next lessons. For now, practice plain if. Write 5 conditions. Watch which bodies run and which are skipped. The rest builds on this. Else comes next. Thanks for learning the if statement. Next time we add else, the alternative path. The foundation is set.